Good afternoon, everyone. Welcome to CPA's educational session. Today, the Contract Packaging Association is pleased to present the dispelling of myths about cooperative palletizing, featuring Tripp and Maxx. Today, we'll give you a broader perspective on cooperative robotic systems. Recently, headlines grabbed your attention by focusing almost exclusively on the use of cobots in contract packaging. There are situations where other innovative options to cobots exist. I'm Paige Jarvie, Director of Association Services for the Contract Packaging Association, and I'll be your moderator today. A short overview of CPA. We have been promoting the growth and welfare of members through its industry exposure and networking program since 1992. CPA members are comprised of the nation's leading contract packagers and manufacturers who perform all types of manufacturing and packaging functions for brands and CPGs. Next slide. The Contract Packaging Association serves as the connection point for the industry through continuing education, market knowledge, and customer relationships. One of the key components of our mission is education. Today's session is an ongoing commitment to inform the industry on innovations as well as to stimulate the audience. Next slide. While members join the CPA for many reasons, by far the greatest benefits received, so they tell us, is the networking with users of contract packaging services, suppliers, and industry, and to other members. Just want to remind everybody that CPA is attending Pack Expo, or I should say is exhibiting at Pack Expo Las Vegas in September. So please stop by our booth 1256. And remember, there's a social networking event on Monday, September 11th, starting at 3:30. We'll also be at Natural Products Expo East in September, and we'll be hosting a networking reception during PLMA in Chicago in November. It's just across the street from the Rosemont Center at the Embassy Suites. And you guys are all invited. So quickly before we get started, and I let Maxx and Tripp take it away, a few housekeeping items. Everybody has been on mute. At the end of today's session, there'll be a brief survey, so we would appreciate if you would provide us your feedback. And the entire webinar is going to be recorded and will be posted on our website. So as Tripp and Maxx get into their presentation, if you do have any questions, we will ask that you put them in the Q&A function, and we will get to them at the end of the session. Again, today's presenters are Max Wright of Formic and Tripp Griffen of Pearson Packaging, who both have experience on cobots and robot solutions, so they can present an agnostic view between the two. Each of our panelists will provide a brief overview of their company and experience. And I then turn it over to you, Max and Tripp, for your presentation. Thanks so much.
Thanks, Paige. Yeah, no problem. And Tripp and I are going to keep it fun today. We know that there's lots of webinars floating around on LinkedIn, and so feel free to keep your questions and log them in at the end. We'll go through all of those. We thought we'd go with a fun Mythbusters theme today, so there's some common myths that we want to go through. But before we get started, Tripp and I have quite a history of busting myths, and we wanted to go through a couple of those.
Yeah, Max, I know you recently relocated to the Oklahoma area, and there's no better myth to dispel than that of the Sasquatch, the infamous elusive Sasquatch that runs the woods. So I'd love for you to bust that one for us while we're here.
Yeah, absolutely. Well, this one in particular turned out to be just a guy in a suit. So Tulsa Park Service was promoting parks here in Southeast Oklahoma, and took some fun pictures, had a good time, but made it big all over Instagram. So but yeah, Oklahoma, strangely enough, known for some Bigfoot sightings, but that was a good one. And Tripp, I know that one of your favorite legendary figures is the Tooth Fairy. And I'm sorry to bust this for you, but I know that Hollywood recently did an expose on this not too long ago, and it's none other than Larry the Cable Guy. Yeah. So
I love me some Tooth Fairy, but I'm very glad to know that Larry the Cable Guy is not it. Unless he's coming with jokes, it's waking up to Larry the Cable Guy in my room, putting some money under my pillow, may be a little bit scary. So
Those, you had me at pink overalls, Tripp. I'm not gonna lie, that's the best part about this. So that's another myth busted. And so now that we've established a credibility, we can kind of get into the big myth we're talking about today, which is there's a lot of talk about collaborative systems all over LinkedIn, right, Tripp? And they can cast a shadow on some of the larger industrial systems, right? They can kind of create some myths.
Yeah, absolutely. That's a great point. And I think kudos to the marketing teams that have promoted this new technology. And it's been out for several years, but it's really gained traction in the palletizing specific market over the past 4 or 5 years. And it has a great place and it's a great technology. And kudos to those as well that have developed it and pushed it out. But it's not always the right fit. And I think that's what our target today maybe is to really evaluate customers' applications and where's the right fit and what's the right solution. So.
Right. And then when you're interacting with robots, collaborative isn't the only way to do it. I know the International Federation of Robotics has come out. We've all seen these terms floating around. It was just in a post this morning on my LinkedIn feed. And what we really want to do is focus on cooperative and collaborative, these two definitions here. I know, Tripp, you and I have both done all of these, right? And I know that, Pearson has some cooperative systems, right?
Yeah, absolutely. That's a good point. And for today's purposes, really, there's 3 of them there that we're really not going to talk about. But we're really going to focus on the collaborative compared to the cooperative. And we would call maybe the cooperative collaborative's big brother. It does have that connotation of being the bigger, bulkier thing, but I think we'll dispel some of those myths around that as well.
Absolutely. Absolutely.
And so really the big key things, I think there's 3 or 4 maybe key components that really separate those activities. It's the collaboratives have a fence, collaboratives don't require the fence. They have those sensors and they're really designed for lower weights, lower speeds, and ideally for small footprints. Where the cooperative, comes with the light curtains, it comes with the fencing, but still allows you with some of our standard pre-engineered solutions, that interaction between the operator and the process. And so the question I really always have is really what is the need for that operator's exposure into the collaborative workforce, work envelope?
Yeah, and I know the Pearson cooperative systems. They use things like light curtains. They use things like safety fence to allow users to kind of enter a cell, right, and maybe change out a slip sheet or change out a pallet without having to shut the whole thing down like a larger fully separated industrial system. So yeah, what are some? Do you want to just take us through the 2 systems that Pearson has that are considered cooperative, Tripp?
Yeah, absolutely. Yeah, and so the one on the left is a single cell, single pallet location. And in the previous picture, you saw the guy standing there. So, if you needed to come in and you introduce a slip sheet, put some corner protectors on, do a layer sheet of some sort, you could go in, request entry, the robot's going to go to a perch position. It's going to allow that operator to have that interaction, go back out and start right back over and remember right where it was in the process. And then the one on the right is the dual floor. You've got 2 pallet stations, you got 2 zones. And this one allows for continuous operation. While that operator comes into that zone A, they can do those functions, corner protectors, labels, small layer of stretch film, as long as they don't break the individual layer between. But as the operator comes in, you can see the robot slows down a little bit and kind of gives you that collaborative feel and allows the operator to perform those functions without shutting down any operations.
These are nifty. I really like these cells, Tripp, and I know we'll get into them a little bit more. What are some other myths that we have about cooperative robots, right? I guess we could start with size, right? That cooperative systems featuring an industrial robot are just too big. With safety fencing, you're kind of looking out over a floor and you're thinking, where am I going to put this thing, right, Tripp? Especially for co-packagers and co-manufacturers. You all fit a lot of stuff on your floors, and it's constantly changing.
Yeah, no, that's a great point. And it really again comes down to the question I ask is, what is that need for the operator to be in that environment? And at the end of the day, we can when you add scanners or you consider the work envelope and the approach envelope of the collaborative robot, you almost equal the same or even bigger footprint of what our RPCC is, our RPCDF, which is the single cell or the dual floor. What you see here represented on the left is the dual floor footprint that our standard cell takes up compared to the one on the right, which is your collaborative.
So it gets, you have a smaller system than that, Tripp?
Yeah, absolutely. That single cell, the one that we looked at, what the guy was standing at earlier, it's actually even smaller. It's a 10x7 footprint.
Gotcha. Okay, so this is slightly larger, but it's still smaller, and operators can kind of get right up next to that robot. Even though that safety fencing is there, you can get a lot closer to that robot than you would be able to with a collaborative before the system slows or stops completely.
Correct. Yep. Yeah.
Yeah.
We run into a lot of applications. Just as a little story, we had a protein manufacturer where they had multiple lines in parallel, and they had short ceiling heights. And so we were able to actually squeeze the footprint of that down just a little bit more. Obviously, we have to run through simulations to make sure that there's no encroachment on the guarding, but we have had even smaller footprints that we've been able to achieve than what our standard offering is.
Yeah, absolutely. That's great. Yeah, so I think we can consider this one busted as far as industrial robots needing to have a bigger enclosure. And I know that we've successfully deployed quite a few of these cooperative style palletizers, and they're nestled into a corner, right? They're right up against a wall, and you can do that with having the safety fence in an area. And it's kind of like when you're buying a new car, Tripp, and you want to make sure it's fitting in your garage. Right.
Yeah, absolutely. Yeah. I've replaced very many side view mirrors on my wife's vehicle because it didn't quite fit in the garage, and we forget to pull them in when backing out. So absolutely, that's a good point.
Well, and cars are pretty easy for garages, right? Because you're rolling them in and out. You can move them all the time if you need to. I guess that leads us to our next myth, Tripp, that I've heard quite a bit, which is industrial robots that are using cooperative palletizers, that they're too hard to move around. Can we speak to this one just a little bit, I guess, in terms of the Pearson systems?
Yeah, no, that's a great point. And honestly, Max, I might give this one to collaboratives, especially some of them out there that come in with the locking casters. They can roll into place. You can disconnect electrical and pneumatics and move them into place. But still, our RPCC that you see there has the frame that's built where the forklift can come in and pick it and move it around from line to line, position to position. And again, the question I would always ask is, what is really the requirement? What demands that mobility be a need or a necessary? Are they moving it multiple times a day? Are they moving it multiple times a week or multiple times a month? And then why is that need? And if there's truly that need of mobility multiple times a day or multiple times a week, then maybe the casters with the wheels with the lock-in may be more advantageous. But at the end of the day, if mobility is not really that key and critical, we still offer the ability to move our RPCC and the RPCDF, the single or the dual floor platforms around.
Yeah, and this is a great feature to talk about, on cooperative systems, the Pearson style systems or other systems that you see out there. We were just out west at a co-manufacturer partner of ours, and they were increasing the volume of their contract. Right. And so the first thing they did was take us to another room and say, hey, actually, this is where we want to be in the next couple months, but we need the automation now. Right. So this was a great feature to talk about and show off, just because, it is so easy to move. Right. If you have a forklift, you can, insert it. If you're able to take it off the truck, right, when this system arrives, then you're able to move it around the facility.
Yeah, that's a good point. And, Max, I don't know, let me ask you this, also from a mobility standpoint, anytime you move something in an industrial environment, there's risk associated with running it into things or running it over drains and causing vibrations, or getting it into the right position, the right point, because consistency with robotics is key, and going to that same robotic pick point is important. What have you guys done in the past that kind of helps mitigate and ensure that the customer gets the equipment in the right spot?
Yeah, so we've done tape, we've done paint on the floor, and we just say, hey, this was where the back left corner of the system. So typically we've done this when you have a wash down scenario, right? So you can always, whenever you walk into a facility and you see a drain somewhere near equipment, we kind of get cold sweats as system integrators. But these kind of systems actually make a scenario like that. Hey, if you want to wash down your area, every month, or you want to wash down a room every 6 months or whatever is required. I mean, we've had people buy industrial systems from us that are moved weekly. You can pick this whole thing up, you can move it away, and then you can bring it right back to where that tape mark or paint mark was down on the floor and align that back corner. And because they're on a standard base, there's nothing in the system that's getting shuffled around, right? So you don't have to reteach the pallet points. You don't have to reteach the conveyor pick points. It's all, that is all contained. So as long as you get in the same spot on the floor and you know your upstream conveyor is going to connect where you intended it to, so we're not missing the palletizer completely, it's fairly robust and it's an easy system to move around if needed.
Yeah, there's two good points that I want to highlight that you brought up that I didn't even think about previously, is that the cell as you see it comes with that in-feed pick point conveyor. So we're not having to assume that we're picking from an external conveyor. That way you get consistency there. That way when it is moved, it's into the right position contained inside.
Yeah, it's all curated, right? It's
Yeah.
the Pearson special package inside those safety fences, right?
Yep. And then also the durability standpoint, as you see it, there's a very robust welded steel frame there and a platform that the robot sits on. So again, there's that mobility risk with of challenging the durability of the equipment that's mounted to. So
Yeah,
just
so
wanted to
I
highlight
mean,
a really good point.
I put in the title, but I think this one's busted as well. There are these cooperative systems that they are movable. You don't have to bolt down, epoxy down every industrial robot cell that is out there. And so if you need to interact with the system more, if you know as a co-packager or a co-manufacturer that you need to move your system around at some point, there's a real peace of mind with these contained cooperative systems. But speaking of all this, like we can't really talk about moving to a new room or using this on a new contract without talking about programming, right, Tripp? There is a stigma that industrial robots are hard to reprogram. They're hard to change over to a new line, and I think this is a key one for us to talk a little bit about.
No, that's a great one, Max. That is, and there is that exposure and that experience that people have had in the marketplace to where anytime they wanted to introduce a new recipe or make a change or a modification to the pallet pattern, we've all had that customer, that big box retailer, that big box customer that all of a sudden wants to go from 5 layers to 6 layers or from 6 layers to 7 layers, and so not having to have a technician come out and manage it through a teach pendant and do it. Operators with our user-centric design, you can see a kind of little representation there on the screen. The user-centric design is really just an operator interface software program that allows the operator or the technician or the customer or Formic to come in and create a recipe right on the screen or modify the existing recipe right on the screen with the HMI.
And Formic doesn't, classify a system as cooperative unless it has this functionality. So this is a really great thing to talk about, and being able to, deploy, new palette patterns on the fly, right, without having to send it back to an integrator or to Formic to reprogram. That's time, right? And time is money, if you can do this with your team on your floor, then that's great. And we offer both Formic and Pearson, we offer confirmation. So, if you put a pallet pattern together and you just want to make sure that it's going to work and it's going to be rock solid, that's all wrapped up in the Formic contract. So your hourly price doesn't change. If you want to add a pallet pattern in the future, we'll do all that with our technicians, and we'll run simulations and offline programming to make sure that everything's going to work the way it's supposed to for your particular system.
Yeah, that's a great point. And with that as well, talking about flexibility, the changeovers, what you see there is the end of arm tool that picks the product. And if you're going from an 8-inch case to a 16-inch case, you'll have a quick changeover of the tool to make those adjustments. The screen shows you where those adjustments are and what they correlate to that recipe so that you can lock those handles in and ensure. But if you're going from an 8-inch case long case to a 10-inch long case, you may not even need to make that adjustment. You just go into the screen, select a separate recipe and start it off. So it's very, very user friendly. And that's really the whole purpose of the user-centric design that Pearson came out with.
Yeah, I love these tools. I mean, this is really cool. And again, this is a great selling point. And we've had customers really enjoy being able to scale their tool as needed if they're going to go to a new line that has just these really large cases. Now this isn't on the fly, right? This isn't in the middle of a production run, right?
Oh, no, absolutely. I mean, it's yeah, you want to stop the machine, pull out existing pallet. Did I lose you? Oh, there you go. Sorry. I had a screen pop up. Sorry. Love technology, right? No, it's no, absolutely. You definitely want to go into a stop mode, e-stop mode, and pull out the existing pallet. Reintroduce the new pallet, empty pallet, do the changeover. But the biggest. I mean, this could be done in less than 2 minutes, less than 3 minutes.
Oh wow!
If you're actually having to go in and make the adjustments to the tool.
You're saying so easy a product manager could do it. Is that what you're saying? Sure.
I'm saying even Maxx can do it. You know?
Yeah, right. Love
It's
it.
funny. There's a little bit of a backstory to the user-centric design is that we partnered one of the universities in Washington to develop it 10 years ago. And whenever they introduced it, they had the lady from HR come out, and then they said, if she can create a new palette recipe or a new pattern, then we've achieved what we were looking for. And her having no exposure or experience to actually putting her hands on the equipment was able to set up and perform a successful palette.
That's awesome. Yeah, and I got to play with that last month when I was out there, and it's you know it's super simple. So this is a nice aspect. And again, you know, if Formic's going to buy something called a cooperative palletizer, it's going to have this functionality included and have these scalable end of arm tools. So yeah, this is great. I mean, Tripp, honestly though, all of this looks kind of pricey, right? You developed this with a university. This is R&D stuff. How much is this going to set us back?
Yeah, great question. Great question. At the end of the day, you got to ask what's the total cost of ownership, right? And how does that play into it? What is you know, what is your future goals and plans for growth? What does that look like as well? You know, if you're going from 5 cases a minute to 7 cases a minute is your target plan over the next 3 years. And then again, with mobility, you want robust piece of equipment that you're not constantly having to deal with downtime and change parts. Unfortunately, in our current environment of supply chain challenges, getting parts in for replacement can sometimes be much longer than what it used to be. So there's lots of things there. And at the end of the day, I think you guys are really uniquely positioned as Formic to provide a really good, solid position for the customer to really understand what is the best fit for them, what's the right program for them, and you know, go from there. So.
Yeah, so cooperative systems, right? They have this higher payload. They have a much higher payload capacity than other systems on the market, right? They have a higher speed tolerance than all the other systems on the market, right? You know, we can go up to 12 cases per minute if we're just picking single cases at a time. You know, we can pick up to 50 kilograms payload. I know the end of arm tool changes all that, but Tripp, could you just share how that has impacted your customer conversations you know, when they're looking down the road?
Yeah, no, for sure. That's a great question, Maxx. And you know, quite often, because collaborative robots are so cool, the technology is amazing, and the marketing teams have done a fantastic job of introducing it to the market, that we get requests on a regular basis of, hey, I want a collaborative palletizer. And
Same. Yep.
Yeah, right. And so there's a lot of times that once you start really asking the questions of what's the fit, what's your application, what's your mobility, what's your future growth plans, we quickly start to understand that maybe the collaborative is not the right fit, the cooperative is. I mean, I just got an example of a story of a guy who did a proof of concept is, you know, Eddie, we'll call him Eddie. He went and bought a collaborative robot, had his maintenance team fabricate a little stand. He did his own little thing, proof of concept. He ran it for 18 months in-house. And he quickly understood after those 18 months that he probably should have bought a cooperative palletizer out of the gate, because he would have been in full production 12 months earlier, 6 months earlier, and you know, with the time to build and everything. So there's absolutely to your point there, that's definitely something to take into consideration.
Yeah, and you know, we just deployed a similar story. We deployed 3 collaborative systems on lower speed, lower weight lines, which is great. And then, you know, the customer said, hey, we really we want to take on a higher volume contract. We want to move more of these things a month, and so we, you know, deployed a cooperative system, you know, on the next line down. And so we didn't take out the collaborative systems in that scenario, but you know, if they want to increase, you know, we've kind of maxed out those collaboratives on the first 3 lines. So if they want to increase into a higher volume, you know, we're bumped right up into cooperative mode right away. And so there is that limit, right? There is that limited functionality that's related with that. You know, I think if we had gone backwards, you know, we might say, hey, you know, let's just do cooperative systems on all of these lines, and then, you know, not have to push all that extra volume to that 4th line. So you know, there is that kind of sense of, hey, you know, if we do a, you know, $100,000 or $200,000 collaborative system, is that going to expand and scale with our business plans? Yeah. Now, obviously, with Formic, the conversation changes, right? You know, we talk about capital purchases versus robots as a service all the time. If you haven't seen one of the Formic webinars or discussions at one of the trade shows, or if you're going to be at Pack Expo in September, we'll be there talking about the same thing. But it's a really no risk ownership style. And not to do too much of a sales plug here, but if you invest right away in a collaborative system, you incur these costs all the way down the road, and then you may not be able to use it as you expand your volume or increase your rates or weights. You get a bigger box on one of your contracts, just like you were talking about earlier, Tripp, with the big box retailers. Regardless of collaborative or cooperative system with Formic, you can deploy those and not have later on down the road, you say, hey, I need a bigger system and we need to put something else in. We have a Formic Flex program that'll allow you to change system types, within a similar category, a similar price range, without, changing your contract. And so that's a really been an attractive and interesting selling point, and so paired with the Pearson expertise and the quality of systems that you're putting out that we've kind of looked at throughout the rest of this webinar, that there's a lot of attractive options there that we can both leverage.
So Max, let me ask you that on that point. If a customer decides they want to go the collaborative robot path, they get it out there, they run it for 12 months, and they decide that, hey, we've earned this big contract from the customer. Our capacity is going to go from 5 cases a minute to 8 cases a minute, and we don't feel comfortable that the collaborative robot is going to be able to support that demand. You guys have a service, or what'd you call that? The Flex?
A Formic Flex. Yep.
Flex.
So
that
again,
operator, they can come in and trade it out for a cooperative robot.
Yeah, absolutely. And again, it's, we have price categories, so we can talk about that when we're putting the contract together, what kind of falls into that price category. There's definitely, you can buy a system, you can buy a $2 million palletizing system if you want to, but this is, still capable of handling, what you're trying to do on your lines. And it's within the same rough scope of the original contract. But all through here, I wanted to say too, on that point, Tripp, we've never had someone get a cooperative industrial palletizing system and decide to replace it with a collaborative system. We've never seen that. And I would even say in my past lives, like that wasn't a conversation that was really had. But we have a ton of conversations, and I would say daily. Hey, we have this collaborative robot. It was great. It was a great way for us to dip our toe, into automation, understand how it works. But would Formic bring in kind of a heavier payload, faster moving industrial system to keep up with our business model? And Formic equalizes the playing field here. If you want a collaborative system, it's going to be the same price as one of these cooperative systems. The RPCC is the exact same price as a 1 in 2 out in collaborative system. So I threw some prices up here on the screen, and this corresponds, by the way, 175, 275, 375. That corresponds typically to how many shifts you're running per month. So the more shifts you run, the more hours you use, and the less expensive the robot is per hour. And so that's kind of what I'm showing up here.
Yeah, that's one of the things I really like about Formic's RAS model, is that it allows the operator or the customer to really test the waters, tip their toes, and to find out if which way is best. And you have that flexibility, because a capital expenditure, that's a commitment. Whether it's 10 years, 15 years, 20 years, you're going to have that piece of equipment, and trying to find a rehome for it, or resell it, or replace it, put it somewhere else. That's a commitment. And through Formic, you guys offer them the opportunity. So I got a question. What's kind of a minimum contract exposure that you guys have?
Yeah, so our minimum contract exposure is 1 year. So actually, all these prices that you see on the screen, this is for a 1 year contract. And we've really zoned in and targeted the 1 year contracts because a lot of times folks come to us, especially co-packagers and co-manufacturers, and they're not starting a new contract and trying to get automation for it. They're mid-contract, right? They're like, hey, I've got another 2 years on this, and we need automation to keep up. It's hard to source labor right now. And also palletizing is just a really hard job. I've done it. I did it in high school. And that was one of my least favorite jobs in the world. I mean, these are heavy boxes, and we're moving them for the entire shift. So this is a really good fit for robotics, right? It's repetitive, it's heavy, and you do it pretty much the entire shift, or 2 shifts or 3 shifts, however many you run a day.
I had one guy tell me that he looked at it as getting paid to work out. He was lifting 30-pound boxes all day long, and young strapping guy. But no, to your point, finding
In
somebody
high
who wants to show
school,
up
yeah,
in high
I
school.
was that guy in high school. Yeah, absolutely.
Yeah, but finding that person who wants to come in and do that all day long is becoming more and more challenging, for sure.
Absolutely. And we've geared these, prices for the Pearson equipment. We've geared this to match the hourly rates that we're seeing, the labor rates that we're seeing. So if it's a really good job for a robot to do, we want to try to remove all the barriers for that. We get a lot of questions too. Hey, yeah, you're saying this robot is, $19.75 an hour, $14.75 an hour, what have you. But what's the catch? I have my facility is in North Dakota, right? And all of our installation, shipping, commissioning, and service is included in these hourly prices. So we are really trying to make it easy.
What about freight?
Yeah, shipping is included. Yep, freight's included. So
Okay, yeah.
we build that estimation up front. And anyway, I just wanted to mention that's part of these hourly prices. So to wrap up this slide, Tripp, you can buy a Pearson RPCC system or a collaborative system, for the exact same price, and the bang for your buck that you get with the cooperative system is worth it. To go back to your point on the previous slide, if your business needs change in a year or in 2 years, it's a lot easier to keep the same piece of machinery on your floor than go out and try to get something else in.
Well, and I think the key there, the name is contract packaging, contract manufacturer. So they're under a contract for X number of term. And, sometimes those are 3 to 5 years, sometimes they're 10-year. But, I've run into contract manufacturers and packagers who have, dialed in and won the business based off of what their cost to perform that service over 3 years. And then after 3 years, they're going to doing something else for somebody else. And so sometimes those capital expenditures don't translate over into the new production needs of that next contract. So
Yeah,
that's
yeah,
awesome.
absolutely. Well, and again, I mean, and we can match the contract terms, right? So if you want a 3-5 year contract, these numbers are all going to go down. And we see that again and again, especially in the way that Pearson has designed their systems. These are completely enclosed modules, right? We're deploying this standard palletizer. And so that makes it really easy to kind of understand where the system begins and ends, where the scope begins and ends, and you're able to move it, between lines really easily over if you want a 3-year contract. But maybe you're thinking, hey, we might use a different room in this facility, or 3 years down the road, we might be in the same contract, but wanting to do something different. These systems and the flexibility Pearson has built in really allows you to do that. So, this, I think we can call this myth thoroughly busted as far as expense goes, right, Tripp?
100%.
I think that's all of them. I mean, we talked about palletizers being too hard to work with. These collaborative palletizers have an edge over cooperatives in palletizing. And I just don't think that's true, especially because palletizing really isn't a collaborative operation, right? We're not working on the same thing at the same time. We might be showing up to put in a new pallet or take out an old one, or a filled pallet, or put in a slip sheet mid-tier or a top cap or something, but we're not, helping the robot pick up a box, right?
Yeah, no, absolutely.
I think that's busted. Myth number 2, being too big. We're smaller than the safety scanner zones on a collaborative system. And again, you can get really close to the palletizing operation right outside that safety fence and still be fully protected and with Cat 3 safety. So I think.
Yeah, I'm sorry. I think that's another question I'd always like to ask. What are you palletizing? Is it basketballs or feathers or lightweight products? Or is it knives and bricks and blocks of something that if that operator is working close in the proximity and you get a drop and the box falls or something falls out the bottom, it's poorly sealed, poor quality, there's risk there as well. Whereas with the cooperative, you've got that fence as a barrier.
Yeah, so I think that one's definitely busted. That's a great point, Tripp. You really don't want to be you don't want to be inside a safety fence or inside a safety scanner if you're moving. Did you say boxes of knives?
Knives, people buy knives, and you got to protect flying out of there like a ninja.
Absolutely. Too hard to move. I think we busted this one as well. I love the same frame designs that Pearson has, Tripp. And the too complex to program or changeover, I mean, this is again is a design consideration. I don't think we would lump these palletizers into cooperative, segment if they weren't easy to reprogram, easy to put new pallet patterns in and adjust if you're going to a totally different line.
Yeah, and I think there's something else that I don't know if we mentioned it or not, but obviously Formic's there as a service that if they're just not sure, they can send you the pallet patterns and you run it through a RoboSim guide and just make sure that the pallet pattern that they're introducing is fit. So it's definitely an additional service that's provided.
Yeah, or whenever we deploy a system, Tripp, we hire or if someone isn't already deployed in that area, we'll hire a service technician within 2 hours of that location. That's our commitment as we grow. And so we're happy to come out and run a pallet through, just make sure everything's working the way it's supposed to. And that's an added level of comfortability on top of the already bulletproof Pearson designs.
Yeah, it's partnership.
Yeah, absolutely. Yeah, you're getting the best of both worlds here. Especially this is the best way to deploy a cooperative system for sure. And then myth number 5, too expensive. Again, we can deploy our lowest rates for 1-year contracts is that 1975 number we saw on that slide. And you can choose if you want a collaborative system or a cooperative system, but in terms of scalability and not wanting to deploy new hardware on your floor, the cooperative is a winner every time in that realm. And yeah, they're not too expensive, but this is a common misconception. And then this is really how all our conversations start, Tripp. So I'm glad we spent time on that.
Yeah, for sure. It kind of reminds me of the Cowboys. Every year we go in, we've got a draft. We're starting preseason. Cowboys are going to the Super Bowl. About halfway through the season, we're like, yeah, that wasn't the right fit. It wasn't the right direction. So
yeah, right. You start with collaborative, and then 4 or 5 conversations in, it's like, yeah, we're probably gonna need to do an industrial system with this. But hey, these make it easy, right? This is these myths that we busted all the way down. I hope this has shed some light on how simple these are to deploy and maintain, especially through Formic and Pearson partnership, right?
Absolutely. Well, Max, let me ask you, what's the best way to get a hold of Formic if now that they've kind of gone through this process and they're looking at replacing that labor with a palletizer? What's the best way to get a hold of the guys at Formic?
Absolutely. You can scan this QR code, go right to our website. There's all kinds of cool buttons to click on. It says, chat with an automation expert. You can send us an email, and this QR code kind of packs the whole punch. So, and I'd also like to open it up, for questions now. If you didn't want to go to the website and ask the other Formic experts on how to do this, but yeah. I mean, we can get you a proposal within a couple of days. We've really worked hard on the partnership between Pearson and Formic to offer these systems for as low as we're able to offer them. So looking forward to hearing from everybody, and that's the best way to move forward.
Thanks, Max.
Awesome. Thanks, Tripp and Max. Much appreciated. Very informative. And like Max said, if you have any questions, you're welcome to go to the QR code. A couple have come in through the little Q&A chat box here. So in what situation would a collaborative system be a better solution versus what you guys have presented around cooperative systems?
It's a good one.
Can we take that one, Max, or?
Yeah, go for it. Yeah.
Yeah, no, I think there's actually absolutely a space for it. And in my opinion, collaborators are great on that high mobility, low rates, low weights. And if you truly have that operator that needs to work in the same envelope, if you've got an operator and you got a tight space and they're really needing to stand there and hold the boxes, because we've all seen the pallets that get stacked and the boxes kind of fray out. So if you need that operator to stand there and kind of help mitigate and manage that, or if you need that operator truly to be in there and do multiple functions while the pallets are being built, then the collaborative is probably the right application for that. And again, to me, that's under 20 pounds, under 5 cases a minute, or close to 5 cases a minute, maybe 6 cases a minute, depending on upstream availabilities. And then obviously the operator in that work envelope. So great question, Paige. Thank you.
Well, and if I could just add something on the end there too, Formic handles machine tending systems, welding systems, and we also do kind of ancillary systems, where we're putting on corner boards or top caps, or we're putting a platen into a case packer, upstream of a case packer. So those are all great operations for a collaborative as well. I would argue that palletizing really isn't a great collaborative function just in and of itself, right? You're typically picking heavy things at a high rate and a rate that's going to increase. But welding is a fantastic application for collaborative robots, just because the comparatively light weight of that end of arm tool, right? Same thing with machine tending. A lot of times it's lightweight parts in and out of CNC machines all day long, and we're trying to maximize space. It's hard to fit in a safety fence around, a couple CNC machines. And so that's a situation where we've deployed a lot of collaborative systems as well. Tripp, I know Pearson has a great, I was reading a page on your website just last week, I swear, and it was talking about putting on top caps onto cases as they're coming down the line. And again, that's a great collaborative operation as well.
Yeah, good point.
It's a cool technology. It really is. I've been told I'm too much of a fan of collaborative systems in the past. So.
And what is an expected lifespan of a cooperative system? How long do they run?
Wow, that's a great question. I think it's if you really look at any industrial piece of equipment and you look at the environment, you look at the operators, that's really and then obviously the demand that's put onto those cells. We've got robotic systems that last 10, 15 years, and we've got some that are out in the market for over 25 years. So we've been doing robotic integration at Pearson for over 35 years, and we've got some robots that are still in production 20 plus years. So it really depends on what kind of quality environment it's in, how well it's taken care of and managed and mitigated. It's just like your car. If you don't get regular oil changes, you shouldn't expect it the lifespan.
Well, and I'll add on there, Formic covers those oil changes for you. So the hourly rate should match your labor. And at the end of the day, we're out there on whatever suggested maintenance plans we feel are optimal, for a Pearson system, for a Fanuc robot. And we have our team of experts that keeps track of that for you.
It's in your best interest for that piece of equipment because you own the asset, right? So it's in your best interest for that piece of equipment to be tended to. So yeah, that's a good point for the Formic model.
And we'll get to one more question here. What's the max payload and speeds of a collaborative system, and are ceiling limits where cooperative systems make sense? And what are the ceilings? Sorry.
Yeah, I'd say for collaborative systems, which we offer as well, we've deployed quite a few of those. We don't want to go much over, and it depends on the robot, right? But if we're putting in a full size collaborative robot, we don't want to go much over 15 or 20 pounds. The higher weight you get with boxes, and I believe you said collaborative, Paige, right? You're asking how much a collaborative system can handle?
Yes.
Okay. Yeah. So the further you get away from the base of the robot, so if you're reaching really far away with a heavy load on a collaborative system, the safety faults really start to abound, right? So the system's being careful, right? And humans and our operators' best interest, we don't want a collision, right? We don't want a collaborative collision, way out in space somewhere, and then the robot doesn't catch it. So the technology stops the robot when it feels like it senses a collision, which can be triggered just by a heavy box. Right, so we really want to use small to medium-sized boxes if we do want to deploy a collaborative system. And again, that's like 15 or 20 pounds typically is where we like to be max, right? That's the top. The lighter the case, the better it is in general for collaborative systems. And rate, nominal speeds, we typically like to see 5 or 6 cases per minute to put it in CPM. There's overspeed, right? Each system is different, but we want to preserve that overspeed for situations where you have a little accumulation or you have a backup and the robot wasn't running. And honestly, collaborative robots experience that backup and accumulation more than cooperative systems because operators unknowingly walk into the safety scanner zones. So that's a system, we're constantly monitoring all of our systems in the field, and that is the number one rate drop on a line is somebody standing inside of a cooperative safety or safety zone without knowing, right? So the collaborative safety zone is this invisible field right around a robot. And when you step into that, the robot actually slows down which then, pushes boxes upstream, right? They're not being palletized, so they're kind of backing up on the conveyor. In order to eat through those and catch back up to whatever's upstream of the palletizer, we need to go faster. And so, we want to preserve, 2 or 3 CPM or 25% typically of that robot speed for that catch up, which is very common. I mean, it doesn't happen, once a day, it doesn't happen once a week, it happens every hour.
Well, thank you. If anybody else has any other questions and we weren't able to get to them, feel free to either scan again the QR code on the screen, or you can email me and I can get you connected with Tripp or Maxx. So again, I just want to thank you, Tripp, and you as well, Maxx, for a great webinar for us. And those of you who were on the line, just quickly before I let you go, CPA does just want to remind you that we have the virtual experience that will run for 3 months on the 3rd Thursday of every month from November to January. And it gives a unique look at focused topics given by leaders in the industry. And that's a precursor, if you will, to the annual event Engage that will be held in Orlando in 2024. So it's a 3-part webinar series that will kind of prelude the annual event again in Orlando in February of 2024. So on behalf of the CPA, thanks for attending, and we look forward to seeing you at our next educational session. Thanks so much.
Thanks, Paige. See you, Max.
Thanks, everybody. Thanks, Paige. Thanks, Tripp.